Hello and welcome to the Chemistry Academy. In this video we're going to go over homologous series in relation to the National 5 chemistry course. So the main homologous series that you look at in National 5 chemistry are alkanes, alkenes, cycloalkanes, and then you also have carboxylic acids and alcohols. We won't be covering carboxylic acids and alcohols in this video, we'll do that in another video. So we're just going to look at the hydrocarbon homologous series in this video. And just to remind you, a hydrocarbon is a substance that contains only carbon and hydrogen. So the three hydrocarbon homologous series that we look at in a National 5 are, like I said, alkanes, alkenes and cycloalkanes. You need to know word for word the definition of a homologous series, and that is a group of molecules with the same general formula and similar chemical properties. You have to be very careful because there is also a definition on isomers, which is relevant to the Unit 2 topic in National 5 Chemistry. And the isomers definition is quite similar to the homologous series one, but they are different. So a lot of people tend to get them mixed up. So try to remember that the homologous series is a group of molecules with the same general formula and similar chemical properties. We're not covering isomers in this video, but just for comparison's sake, the definition of isomers are molecules with the same molecular formula but a different structure. So you can see how the definitions are quite similar. It's the formula bit that tends to get people. So homologous series, a group of molecules with the same general formula and similar chemical properties. So get that on a flashcard. So I've done a summary here of the homologous series and the things that you really need to know about them. So the first group is the alkanes. You'll be able to identify them by name just because the end of the name ends in ane. So it'll be something like pentane or hexane or methane. Anything that ends in ane means it's an alkane. And their general formula, which is essentially the ratio of carbon to hydrogen atoms, or any other atoms if there are any others there, is CnH2n plus 2. So you need to remember that general formula for the alkanes. It can help you identify if something is an alkane from its molecular formula. So if the molecular formula has double the number of hydrogens as it does carbons plus an extra 2, then that tells you it's an alkane. So for example, just a bit of an example here, if we had 2 carbons in an alkane, the hydrogens would be 2 times 2 plus 2. So 2 times 2 is 4 plus 2 is 6. So that would be the alkane with 2 carbons. So that's how the general formulas are useful for identifying, firstly, what homologous series a molecule might be in from its molecular formula, but also working out the molecular formula for a given alkane. So if you knew it had 6 carbons, you could work out how many hydrogens it needs to have. Then the next thing you need to know about the alkanes is that they are saturated molecules. So saturated means they contain all single carbon-to-carbon bonds. So try and remember S and S, saturated single. So they've got all single carbon-to-carbon bonds. And this is an example of an alkane here. So it's useful to be able to identify what family or what homologous series a molecule's from just by looking at it. So for the alkanes, you'll see all straight chained carbons singly bonded to each other. And this specific alkane here is called 2-methylbutane. Again, you can see the name ends in ane. We'll cover naming molecules in a different video, so if you need to brush up on your naming skills, you can go and find that. And this isn't really necessarily taught when you do the subject, but I just think it's useful to bear in mind for certain questions you get in the exam. Just bearing in mind what types of reactions molecules can undergo. So for alkanes, it's generally combustion reactions that we see them doing, so they get burned in oxygen to release energy. So that's the only reaction you'll tend to see them do at National 5. Then if we move on to the alkenes, so their names end in -ene, so quite similar to alkane. This is where your elocution lessons come in handy, pronouncing your words properly. So an alkene will end in -ene, and their general formula is CnH2n, so they've got 2 less hydrogens than their associated alkane. So if we had the alkene with 2 carbons, the number of hydrogens would be 2 times 2, so 4. Okay. They are also unsaturated, So unsaturated means they contain at least one double carbon to carbon bond. I will write the definitions of them on the next board when we get to that stage. So they are unsaturated. That means they will rapidly decolorize bromine solution. And again, I will write this down on the next board, but anything that is unsaturated will rapidly decolorize bromine solution, and that's how we can test to see if the substance is unsaturated or not. The saturated ones won't react with the bromine solution, so they don't decolorize it. So that's how you can tell the difference. Alkenes look something like this, where you've got a double carbon to carbon bond in it, and again from the name it will end in -ene, so you could look at the name of this and tell it's an alkene because it ends in -ene. Again, if you're looking to brush up on your naming rules, just go and have a look at my systematic naming of carbon compounds video instead. The alkenes do have a few more reactions, and they take part in predominantly addition reactions. So if you think of maths, adding equals sign, we don't call it an equals sign in chemistry, but it looks like one. So that's one way to kind of remember that anything with an equals sign can undergo an addition reaction. But in chemical terms, it's anything with a double carbon to carbon bond can undergo an addition reaction. And within the addition reactions, you get specific types of addition reaction. So you can have hydrogenation, so that's when you add hydrogen to the molecule. You can have chlorination, which is where you add chlorine. Then you've got bromination, where you add bromine. And then hydration is where you add water. So hydrogenation and hydration often get confused by people. But if you just remember, we hydrate ourselves by drinking water. So if it's a hydration reaction, you're adding water. Hydrogenation is hydrogenation, like the elements in the name. And they can also undergo combustion reactions as well. But it's addition reactions you'll see them mostly do. And again, I'll have a separate video on addition reactions of alkenes if that's something you're wanting to brush up on as well. And then the last homologous series of the hydrocarbon substances that we look at National 5 are the cycloalkanes. So their name ends in -ane, like alkanes, but they have a cyclo at the start of the name. So you'll see their name being like cyclohexane or cyclobutane or something like that. And they actually have the same general formula as the alkenes, but they have different structures because they're arranged like a ring. So they don't have a double carbon to carbon bond, they are saturated, it's all single carbon to carbon bonds, but they always have like a cyclic ring formation within the molecule. So if we have a cycloalkane with 2 carbons, we'll have 2 times 2, 4 hydrogens. So the molecular weight, or the formula, molecular weight, whatever, it ends up being the same thing. They'll both be the same for an alkene and a cycloalkane with the same number of carbons. So in order to tell the difference between them, what we usually do is we do the test for unsaturation, because the alkene will rapidly decolorize bromine solution, but the cycloalkane won't. So we know they have the same molecular formula, therefore they'll have the same molecular mass. So to tell the difference between them, to decide which one was which, we would test with bromine solution, and the alkene would decolorize it rapidly and the cycloalkane would not. Like I said, here's what you can look for when you're trying to identify one from the structure. They make like a wee ring formation. And the reactions you'll only really see them undergo will be like combustion. They're not really that reactive, because the alkenes are more reactive because they've got that double carbon to carbon bond functional group. Okay, so we'll move on to writing the definitions of the saturated and unsaturated, and also have a look at the test for unsaturation. So to finish off, we've got the definitions of saturated and unsaturated that I've already said already, but just remember the saturated means it contains all single carbon to carbon bonds, so S and S. And then the unsaturated means it contains at least one double carbon to carbon bond, so you'd be looking for that functional group there to state that it's unsaturated. Then again, the chemical test for unsaturation is you would add bromine solution to your substance, and if it rapidly decolorizes, then it is unsaturated. And the word rapidly is extremely important. If you don't have the word rapidly, you won't get the mark, okay? Then lastly, we've got patterns in physical properties. So this is a question, these questions get asked about semi-regularly, and essentially based on how large the molecules are, you can tell or predict what their sort of patterns in their properties will be. So got the first 4 alkanes written here. If you are looking for the molecules that are in the homologous series, you will find the names of the first 8 alkanes and then the first few alkenes and the first few cycloalkanes and things on page 9 of the data booklet, along with their melting and boiling points. So you can always look there at page 9 if you are doing any questions on homologous series and want to look at some of the properties and things, or the names. Just if you're doing naming, it can remind you of what the structure of the name for that homologous series is. So as we go down from methane to butane, they're increasing in size because you're getting increasing numbers of carbons, so then you're also going to have more hydrogens. So they're increasing in size, and as they increase in size, their boiling point will increase. They quite often ask you why that is the case, and for this, in the case of these covalent molecules, if the molecule is larger, then they have stronger attractions between their molecules, and that's what's getting broken when we melt or boil any covalent molecules. So we don't break the bonds in the molecule. So if I just draw a little methane here, we don't break the bonds between the carbon and the hydrogen when we melt it. All we're doing is moving the methane molecules further apart. So there's little attractions that occur between the molecules, and it's them that get broken. Okay, so they're the intermolecular attractions that we break. And the bigger the molecule, the more of those attractions they will have, which is why you then need more energy or like a higher temperature in order to break them. Okay, so they're known as intermolecular attractions because they happen between 2 different molecules, and that's what's broken when you melt or boil a covalent molecule. So just remember, the bigger the molecule, the stronger those intermolecular attractions will be, or you can say that they've got stronger attractions between their molecules, as long as you reference that it's attractions that are between the molecules. So if a molecule is very small, like I said, generally it has a very low boiling point, so it will usually be a gas at room temperature, and that's because it has weak attractions between its molecules. So it's very easy, to turn it into a gas. Okay. And then as the molecules get bigger, you also need to remember that then they become less soluble in water, so they don't dissolve as easily in water as they get bigger. Okay, so as they increase in size, the boiling point increases because the bigger molecules have stronger attractions between their molecules, and the solubility in water decreases. Okay, so that's my summary on alkanes, alkenes and cycloalkanes. Like I said, if you are looking to brush up on your naming of these molecules, then you can check out my systematic naming National 5 video. But I hope that helped. If you found it useful, please give it a like and don't forget to subscribe. I'll see you again soon.